Hi there, my name's Nicholas Crimes.
And I'm Peter Fritz.
We're going to talk to you in this presentation about the importance of teamwork in difficult airway management.
And the critical role of a new cognitive aid to facilitate this.
Let's start by looking at another well-known crisis, cardiac arrest management. Now, this is something in which the world has adopted a standardised approach, which is accepted by everyone. Everyone who might be involved in managing cardiac arrest is trained in this same simple algorithm. And that means when they come together from different wards, different areas, different backgrounds, in a time-critical situation, they're all on the same page, all doing the same thing.
Okay, so if you look at an airway emergency, surely we're doing the same thing. We've got a team approach. We've got a backup plan that's foolproof, easily understood by all staff, simple cognitive aid, and easily remembered, and your heart rate is 160 and the patient's SATs are 70.
Well, here's what I've got for you then, Pete. This is the ASA difficult airway algorithm. What do you think?
I'm not sure if I like it. Still too many lines, too many ways you could go. It's not simple, concise, and it seems to be very anaesthetic related.
It's also mainly taught to medical staff. I don't know that the nursing staff get exposed to this. But there's another problem. I might be trained with this, but you might prefer using this. This is the DAS algorithm.
Yeah, the problem with this is, I think it depends on which context you're in. Again, it's not that clear.
Yep, so there's one for a fasted patient, one for an unfasted patient. Even then, I don't want you to choose which one you're using yet because there are more options. Because what if it's a trauma situation? What if it's a paediatric situation? What if it's an obstetric situation? Now you end up with a whole lot of different algorithms.
Too many choices.
Not necessarily unjustifiable choices. There are reasons why you might need to do different things in different contexts. But none of these rigid algorithms give you the flexibility to change what you're doing.
And how are we going to know that we're working off the same algorithm?
Well, we're not, because when I rush down to the emergency department to give you a hand, it's quite reasonable that I may not know which of these you're working off.
So what we need is a tool that's simple enough to be used in a stressful situation, but flexible enough to be used in any clinical context.
Correct. And here it is. We call it the Vortex. And it doesn't matter if you work in theatre, ED, ICU, if your initial plan was to intubate or put in an LMA, whether the patient is a child or whether they're with child, whether they're fasted or unfasted. It doesn't matter. It's completely context independent. It works in every clinical situation.
And it's so simple that if you close your eyes now, I bet you can draw it from memory.
And that means it's simple enough for the whole team to visualise in a crisis. And its simplicity and its flexibility make it what we call a high-stakes cognitive tool. And it's best understood by looking at the individual parts. Take us through it, Pete.
There are only 3 non-surgical techniques to obtain a patent airway. And if you've had your best attempt at each of these and the patient is not waking up, you need to prepare to perform an emergency surgical airway regardless of the saturations.
Let's take you through an example of how it works. Say Pete's down in the ED and his plan is to do a rapid sequence induction.
So I'll have my best attempt at intubation if that's my primary plan. And that best attempt may involve a number of goes where I try and optimise things as much as possible. And if I've had my best attempt at intubation and that has failed, I move on to face mask. Again, optimising things as much as possible. And if that fails, move on to laryngeal mask. And again, if that fails, then I have no other option but to proceed to a surgical airway.
Now, the flexibility of this tool means that it doesn't matter which order you attempt each of the non-surgical airway techniques. You can vary this according to the clinical context. So let me take you through an example with a fasted patient in theatre where my primary airway plan might be to insert an LMA. Following my best attempt at LMA insertion, if that fails, I'd then go back to face mask ventilation, have my best attempt at that, and if that fails, my best attempt at intubation. If all of those fail, then again, I need to perform an emergency surgical airway.
Conversely, if you're successful with any of the non-surgical techniques, you move out into what we call the green zone. So in the green zone, I can confirm that alveolar oxygen delivery is occurring. It may not be by my intended airway device, but the patient is relatively safe from imminent hypoxia.
And that means that you've bought some time. Time to restore the patient's saturations as much as possible, time to assemble your resources, and time to make a plan.
The whole team is able to contribute to getting the patient into the green zone using a short checklist of 5 optimisation strategies that are applicable to all 3 non-surgical airway techniques.
Different members of the team are able to prompt the primary airway operator to ensure that an optimal attempt at each non-surgical airway technique is had as efficiently as possible and in the minimum number of goes.
We're in the green zone now.
Difficult airway management essentially amounts to a four-step process. An optimal attempt at a non-surgical airway, an emergency surgical airway if that fails, and then restoration of alveolar oxygen delivery via either non-surgical or emergency surgical airway techniques. Time is then available to go on and make preparations to establish a definitive airway. This conceptual diagram shows how the vortex would fit into that four-step approach. In being goal rather than technique directed, it gives the team the flexibility to manage a difficult airway in any clinical situation using the same basic template.
This means that everyone can be trained to use this standard template just as they do in cardiac arrest management, so that when the team is actually thrown together to manage an airway crisis, they already have a shared mental model of what needs to be done. So like cardiac arrest, difficult airway management is a situation which is high stakes and time critical.
So when managing a difficult airway, we shouldn't be in a situation where different team members are potentially working on multiple different algorithms.
So we should all be using a consistent approach, and the Vortex provides that.
And supports it with an interprofessional training program.
Whether you're ED, ICU or anaesthetics,
Whether you're from a nursing background, medical or paramedical.
whether your plan is to intubate or place an LMA.
The patient can be sick or well, an adult or a child, fasted or unfasted.
The team will always know that this is the plan.
This is the way we've managed cardiac arrest for decades. It's time for the way we manage difficult airways to change. It's time for a team approach.